Hello, and welcome to Commercial Smoke Vents Design Application Essentials for Life Safety and Welfare provided by Babcock Davis. My name is Chris Casa, and I'm the Architectural and Design Specification Manager with Babcock Davis, and I'd like to thank you for attending this educational CEU course. Babcock Davis is a building products manufacturer servicing the product portfolio you see on your screen. We know that sourcing commercial building products is never as simple as it seems. This is particularly true when it comes to the type of specialty and architectural building products that we supply. It takes a collaborative effort of resources and information to get the job done right. We understand all the complexities and time sensitivities involved, and this is why we've built such a strong network of people and processes to better serve all of you, our partners, and we do so with flexibility that meets your needs, not ours. Obviously, Babcock Davis philosophy is customer first. As your partner at the distribution and local service level, we support your business and provide solutions to improve your bottom line. Babcock Davis has been around since 1909. We've been an industry leader in roofing products, service, quality, and can tailor to suit your organization's needs. We work hard to earn your business, and we work even harder to keep it. I'd also like to let you know that Babcock Davis is proud to be an affiliate member of the Health Product Declaration Collaboration, and we offer HPDs on our products whenever possible. You can easily find these on our website. If you go to the product itself, look for the thumbnails and click on the lead information, which will then pull up the HPDs. We have several CEU courses in accordance with AIA credit credentials that can be earned in 3 ways. Number 1, via a live webinar, both public or private. On demand through Ron Blank, which can be accessed by visiting our website and is available for viewing whenever it's convenient for you. And lastly, in person, as it is available and requested. Other courses that we can provide would be roof hatches, safety standard applications and regulations, integrating access doors for function and design, and lastly, green roofing, blending built environments with nature to maximize rooftop productivity. Finally, we're proud to partner with specification tools and services such as RIB SpecLink, Master Spec, along with Deltek SpecPoint, and BIMsmith, which can be accessed through our website or directly. Ron Blank hosts our narrated on-demand CEU courses, and we are also members of AIA, members of SCIP, and members of CSI. And Babcock Davis is located in Minneapolis, Minnesota, and I am a member of my local Minneapolis CSI organization. Now, let's begin the program. Understanding Commercial Smoke Vents, Design and Application Essentials for Life Safety and Well-Being. Babcock Davis presents an American Institute of Architects and International Institute of Building Enclosure Consultants continuing education services program. Credits earned upon completion of this course will be reported to AIA CES for AIA members, and certificates of completion for both AIA members and non-AIA members are available upon request. Credits earned upon completion of this course should be self-reported to IBEC CES for IBEC members, and certificates of completion for both IBEC members and non-members are available upon request. This course is registered with AIA and IBEC CES for continuing professional education. As such, it does not include content that may be deemed or constructed to be an approval or endorsement by the AIA or IBEC of any material of construction or any method or manner of handling, using, distributing, or dealing in any material or product. Please remember that AIA and IBEC require attendees to complete at least 50 minutes of this course. Those attendees that log off before 50 minutes will not receive credit or a certificate of completion. Completion certificates are distributed by email, and they typically take about 10 days to arrive in your inbox. The intent of this course is to explain the benefits of smoke vent design and life safety. Upon completion of this course, the designer will have a better understanding of the code regulations for life safety and will be able to properly size and place vents in accordance with codes. There are 5 learning objectives for this course. The first will be to be able to describe smoke venting application and why it's important to life safety. The second, we will illustrate smoke vent fundamentals, including the opening and closing options. Number 3, we'll outline IBC, IFC codes, as well as NRCA requirements and UL and FM listings. Number 4 will help you to understand the meaning and importance of a thermal break in a smoke vent. And lastly, we'll identify design practices for sizing and selecting operation of smoke vents. So with that, let's start with section 1. In section 1, we're going to describe smoke vent applications and why it's important to life safety. Smoke vents are designed to open automatically to provide emergency smoke, heat, and gas ventilation from a burning building. Smoke vents save lives. The removal of smoke, heat, and toxic gases are critical to allow more time and improved visibility for occupants to exit a building. Additionally, firefighter safety and assistance is improved as the smoke vents eliminates the needs for possible manual roof venting with axes. You can see a firefighter up on the roof here trying to vent the building. That's not a safe thing for the firefighters to do, so the smoke vents help with that venting. And it also reduces the heat and smoke damage to property and contents of the building. So this brings up the why. Why a smoke vent? The screen shows you 2 different scenarios. The first scenario shows a fire without venting. The ideal scenario includes smoke venting as depicted in the second diagram. In this diagram, when the smoke and heat rise, the sprinklers go off to extinguish the fire, and then the smoke vents open to exhaust the smoke and toxic gases. Smoke vents are designed to open automatically when a fire is detected, allowing the smoke to escape from the building. This helps maintain visibility, making it easier for occupants to evacuate, for firefighters to access that building. Smoke vents can also be triggered by smoke detectors or fire alarms, so you can connect a relay to them. Automatic sprinkler systems activate when they detect heat from a fire. They release water to control or extinguish the fire, reducing the spread of flames and limiting damage. The water spray also helps to cool the smoke, making it less dense and toxic. When both systems are in place, the sprinklers work to control the fire and reduce smoke production. While the smoke vents help to remove the smoke that is generated, this combination improves visibility and air quality, aiding in the safe evacuation and the firefighting efforts. It's important that these systems are properly coordinated. For example, smoke vents should not open too early, as this could interfere with the sprinkler system's effectiveness by allowing too much air into the building, which could in turn feed the fire. The following video shows an actual fire in a school where smoke vents were used.
Also right now, investigators are trying to figure out what sparked a fire. This is out of a metro school. This is late breaking news we're updating for you right now. Sky 5 over the scene at Southmore High School. Firefighters say the fire started in the balcony of the auditorium. They don't know how it started. Students were evacuated, then sent home for the day. The good news is we can tell you no reports of any injuries. This morning.
So basically what happened here was that students noticed a fire in the balcony and pulled the fire alarm. The sprinkler system activated and extinguished the fire. The staff were evacuated safely. This happened in the city of Moore, and the fire marshal, Jeff Lindsay, opened the vents manually from the stage floor to vent the smoke vents, thus allowing the heat and gases to escape the building, keeping people from getting injured and damaging more of the school. He commented, in such a large open space, it would have been better to have more smoke vents in other areas besides just above the stage. And without smoke vents, they could have not gotten the smoke out as fast as they did. They would have had to wait until the smoke cooled and dropped to push it out with fans, which would have caused more damage to the school. This was from Southmore High School auditorium in Oklahoma. Smoke venting systems are critical components of building safety infrastructure designed to mitigate the spread of smoke in the event of a fire. These systems are specifically engineered to manage smoke and heat accumulation within enclosed spaces, such as large commercial buildings, warehouses, shopping centers, and industrial facilities. We'll go through the 5 reasons why smoke venting is crucial for life safety. Number 1, smoke inhalation prevention. Number 2, improved visibility. Number 3, reduced fire spread. Number 4, temperature control. And number 5, the preservation of property. The first reason for smoke vents is smoke inhalation prevention. Smoke inhalation is a leading cause of fire-related deaths. Toxic gases and particles present in smoke can cause respiratory problems, disorientation, and even loss of consciousness. By venting smoke out of the building, occupants have a better chance of escaping without succumbing to that smoke inhalation. The second reason for smoke venting is improved visibility. The image on your screen illustrates well how smoke significantly reduces visibility in a smoke-filled room, making it difficult for occupants to find exits and for firefighters to locate and rescue people trapped inside. Venting smoke helps to maintain clearer air, allowing for safer evacuation and firefighting operations. The third reason for smoke venting is reduced fire spread. Smoke contains combustible particles that can ignite fires in other areas of the building. By removing the smoke from the affected area, smoke venting combined with sprinkler systems help prevent the spread of fire to adjacent spaces, containing the fire and limiting property damage. The fourth reason for smoke venting is temperature control. Smoke venting systems not only remove smoke, but also help control the buildup of heat within a structure. Excessive heat can compromise the structural integrity of the building and pose a threat to occupants. Venting smoke helps dissipate heat, reducing the risk of structural collapse. And the fifth reason for smoke venting is the preservation of property and assets. The picture that you see on your screen is a result of a classroom fire at La Follette High School in Madison, Wisconsin. Beyond safeguarding life and health, smoke venting systems also help protect property and assets within commercial buildings. Smoke contains corrosive substances that can damage equipment, machinery, and other valuable assets. By venting smoke promptly, these systems minimize the extent of smoke damage, preserving property, and reducing financial loss. So in summary of section 1, smoke vents are designed to open automatically to provide emergency smoke, heat, and gas ventilation from burning buildings. Smoke vents save lives. The removal of smoke, heat, and toxic gases are critical to allow more time and improve visibility for occupants to exit a building. In addition, firefighter safety and assistance are improved as the smoke vent eliminates the need for manual roof venting with axes, and it also reduces heat and smoke damage to property and contents of the building. Moving on to section 2, we're going to talk all about smoke vents and the fundamentals. So what is involved with smoke vents? What are the piece parts? How do they work, etc. So let's start with smoke vent fundamentals, basically what's common on typical smoke vents. Smoke vents are commonly constructed of steel, aluminum, or a combination of both. Finishes for steel vents, it can be like a baked enamel or a primer or a powder coat. And for aluminum, you could get mill finish aluminum, you could get anodized finishes, and there's also Trinar, Kynar type finishes that can be added to smoke vents. The curb, the standard curb height on a smoke vent is 12 inches so that you can flash it up alongside of the curb and tuck the roofing up underneath that cap flashing. And although 12 inches is the standard, you can get curb heights anywhere between 6 inches and up to 48 inches. Curbs are also insulated, and insulation can vary from manufacturer to manufacturer, but typical insulation on curbs and covers would be polyiso, polystyrene, and mineral wool, just to name a few. There are locking hold open arms on smoke vents once they open up to make sure that they stay in the open position. And also covers are gasketed to prevent moisture infiltration. And the standard warranty on a smoke vent would be 5 years. Also, one last thing to add is door options. So a smoke vent, kind of like a roof hatch, you can get in a single leaf or a double leaf, but you can also get smoke vents for much larger applications in a quad leaf type system, as you see here on the third diagram. Basically, it's 2 vents with 4 doors inside of one singular frame. When designing smoke vents, the most important question that needs to be answered is how is it going to open and how will it close? This screen that we're looking at now is going to be all about how they open. So smoke vents are designed to open automatically when the fusible link reaches a set temperature of 165 degrees. And it can be as high as 450 degrees, and it's often coordinated with sprinkler requirements. You can see the link here on the far left part of your screen. What that does, simply it melts out at 165 degrees. The smoke vents are spring loaded and they pop open. By default, smoke vents are fitted with manual pull cables inside and outside as well. So that they can be tested and manually opened. And then lastly, there is electrical options to open smoke vents. There is a video here. I'm not going to play the video, but it shows a Belimo actuator tied to a fire alarm system that signals when the door should open up. So basically, if the alarm goes off, it triggers or relays to that Belimo. The Belimo then triggers the latch to open and pop open. So for starters, with smoke vent fundamentals, the components are similar to, say, a roof hatch, but they perform in different ways. A roof hatch is meant for egress, and a smoke vent is meant for venting. The natural state of a smoke vent is closed, and they are typically only opened to vent a space. On a smoke vent, you'll have an interior and exterior manual release latch, which is required so the hatch can be activated from the roof if needed. In addition, there's a fusible link with the predetermined meltout temperature that will automatically cause the vent to open when that temperature is reached. So now that we know how a smoke vent opens, how does it close? First off, smoke vents are not easy to close. That natural position is open. They're spring loaded. Those spring forces want to keep the doors open. And there's enough opening force by code to lift 10 pounds of square foot against the theoretical wind or snow load. That might not sound like a lot, but in a standard 4x8 configuration, that's 4 foot by 8 foot configuration, which is kind of your standard smoke vent, the closing force is 320 pounds or about 160 pounds per door in a double door design. And you'll need that same 160 pounds of force to close the door. Options for closing the door include manually from the rooftop. This may take a couple of strong people to put their weight on the unit until it latches. A second option is a manual winch. You can see that here on your screen. The winch is an option frequently used in theater applications where they are rigged down to the stage floor area, where one can crank the winch to close the doors. Additional options include motorized controls. You see the linear actuator up above. They include opening, closing, push buttons, as well as electrical relay ties into the fire alarm system. The code on smoke vents also requires that a dampener be in place to slow the opening of the doors. Without dampeners, those doors would open fast with really deadly force. They're super spring loaded, so they pop open really fast. The dampeners help to slow that down. And lastly, units have been tested independently, but they need to be tested as a system, a working system, to obtain that UL and FM listing. We talked about the opening and closing of smoke vents, and these are just some of the ways that they can open and close. For instance, we talked about the fusible link. The fusible link melts out, and then it pops the vent open when it hits a certain degree, so you can get links that are like I said, 165 degrees all the way up to 450 degrees Fahrenheit. There's a pneumatic actuator that can help to open the smoke vent. There's also an electrical belimo, which opens the smoke vent. There's a relay that you can tie into the fire alarm system so they talk together. You've also got manual pull handles on both the inside and the outside, so that they can be tested, and if one doesn't open up, a firefighter could be up on the roof and manually pull that and open it to vent the building. To close it, and you've got rooftop options, such as these gentlemen up there trying to close the roof hatch. You've also got linear actuators that do the opening and closing. You've got the manual winch, which can crank it down and close it once it's open. And lastly, there is what's called a door position sensor, which is a security feature which just will link back to the security controls and will show when that vent is closed or possibly open. And lastly, here is a quick project spotlight. This is the East Ridge Mall in San Jose, California. This was a re-roofing project at the facility. They chose your standard double door unit with a white powder coat finish for the high solar reflective index. The use of these vents was installed over a 3-story tall atrium with motorized controls so they could be operated from the floor level. I think the visual is good. You can see how many projects have a bunch of 4x8 smoke vents kind of lined up to meet the minimum required venting area on a building. In summary of the fundamentals, smoke vents are commonly constructed of steel, aluminum, or a combination of both, with the standard curb height, which is typically 12 inches and includes insulation and locking hold open arms. And number 2, you need to determine how you want the smoke vent to open and close. Very important questions. Smoke vents are designed to open automatically when the fusible link reaches a set temperature, and by default, they are fitted with manual pull cables, both inside and out. Section 3, smoke vent codes and compliance. In this section, we're going to talk all about codes and smoke vents. NFPA 101 is also known as the Life Safety Code, which addresses smoke vents primarily through requirements related to smoke control systems and fire protection features. Here are some key points of NFPA 101. For smoke control systems, this includes the use of smoke barriers, partitions, and ventilation systems. To compartmentalize and control smoke movement within a building, smoke vents play a crucial role in these systems by providing a means to vent smoke and heat to the outside, aiding in the protection of building occupants and facilitating firefighting efforts. Within the fire protection system, it says these systems must be designed, installed, and maintained according to specific guidelines to ensure they function correctly during an emergency. And then lastly, it talks about regular maintenance and testing, and this includes routine checks to verify automatic opening mechanisms and manual pull stations are functioning correctly. Next, we'll review more NFPA code, code 204. NFPA code 204 is a standard for smoke and heat venting. It has a couple sections: design and installation, inspection and maintenance, and manual and automatic operation. Within the design and installation, these systems are crucial for the emergency venting of combustion products during a fire, ensuring the safety of occupants and facilitating firefighting efforts. And when it comes to inspection and maintenance, this includes annual inspections to ensure all components, such as fusible links, manual release devices, and mechanical parts are functioning correctly. Proper documentation and reporting of these inspections are also required. And then lastly, for manual and automatic operation, smoke vents must be capable of opening automatically at a predetermined temperature. They should also have a manual pull cable for activation by personnel during an emergency. And then lastly, you've got NFPA 92, which outlines the process for designing various smoke control systems. While it doesn't dictate when a smoke control system is required, it does specify how to design such system. For instance, it talks about basic requirements for smoke vents, and it says, while NFPA 92 does not focus exclusively on rooftop smoke vents, it does address overall system requirements. When it comes to activation and system components, NFPA 92 emphasizes automatic activation of smoke control systems. Detection devices such as smoke detectors play a critical role in this process. These devices send signals to control panels, which then activate or shut down various components of the smoke control system. I recommend always consulting the full NFPA 92 code book for projects requiring smoke vents. Smoke vents are required by International Building Code, IBC of 2024, and they are required in sections 410, 910, and 3004. Section 410 is for stages, platforms, and technical production areas such as theaters, performing arts centers, and auditoriums. Section 910 is smoke vents for factories or storage warehouses, and Section 3004 for hoistway venting, which is found in elevator shafts. Also, local state jurisdictions adopt these codes or variants of these minimum requirements, so you always want to check with your local jurisdiction. So let's start with Section 410 for stages, platforms, and technical production areas. It says in Section 410.2.7 for stage ventilation that emergency ventilation shall be provided for stages larger than 1,000 square feet in floor area or with a stage height greater than 50 feet. Also, if you move on to Section 410.2.7.1 for roof vents, it says 2 or more vents constructed to open automatically by approved heat-activated devices with an aggregate clear opening area of not less than 5% of the area of the stage shall be located near the center and above the highest part of the stage area, and the vents shall be labeled. And then lastly, let's go on to the same section, point 2 for smoke control. And it says smoke control in accordance with sections 909 shall be provided to maintain the smoke layer interface not less than 6 feet above the highest level of the assembly seating or above the top of the proscenium opening where the proscenium wall is provided. Next, we'll move on to IBC code section 910. This is going to take us actually 3 slides to go to. It's quite lengthy, But for starters, section 3.1 to 3.4 are listed here in its entirety. Details compliance labeling, location, and operations. For section 910 3.1 for listing and labeling, it says smoke and heat vents shall be listed and labeled to indicate compliance with UL 793 or FM 4430. Section 3.2 in 910 says smoke and heat vent locations, and it says smoke and heat vents shall be located 20 feet or more from adjacent lot lines and firewalls and 10 feet or more from fire barriers. Vents shall be uniformly located within the roof areas in the area of the building where the vents are requested to be installed by section 910.2, with consideration given to roof pitch, sprinkler location, and structural members. And then section 3.4 for vent operation says smoke and heat vents shall be capable of being operated by approved automatic and manual means. On this current slide, we'll talk more about section 910, sections 3.5, 4.5, and 0.5. 3.5 is fusible line temperature rating, and it says where vents are installed in areas provided with automatic fire sprinklers and the vents operate by fusible link, the link shall have a temperature rating of 360 degrees. Basically, they want the smoke vents to open after the sprinkler system has gone off. Section 4.5, manual control location. It says manual controls shall be located where they are able to be accessed by the fire service from an exterior door of the building and separated from the remainder of the building not less than 1 hour fire barriers constructed in accordance with section 707 or horizontal assemblies constructed in accordance with section 711 or both. And then in section 0.5 for maintenance, it says smoke and heat vents and mechanical smoke removal systems shall be maintained in accordance with the International Fire Code. And last of all, when it comes to section 910, it has very specific requirements where smoke vents are mandated. Section 910 covers the factory F1 and S1 occupancy types. Any single-story building greater than 50,000 square feet requires a 1 to 100 vent-to-floor ratio. That is, they want 1 square foot of venting for every 100 square feet of floor area. In addition, the IBC requires smoke vents to be UL 793 listed. F1 type buildings are storage, moderate hazard. Building occupancy is used to manufacture things like vehicles, manufacturing like lithium batteries, whereas S1, storage moderate hazard, is the building occupancy is used for storage of like very burnable things like bags, books, clothing, and so on. To close out this section, let's discuss smoke vent product compliance required in code. These compliances are UL listed and FM approved. So what are the requirements of UL 793 to be specific when it comes to smoke vents? When they test these, they go through 250 cycle tests where they open and close them to make sure that they operate correctly throughout those cycle of tests. They operate with UL 33 listed heat response devices or fusible links in the range of 160 degrees Fahrenheit to 520 degrees Fahrenheit. It says they need to operate manually from inside or outside of the building, and that's the pull handles we talked about. They need to open against a snow load of 10 psf per door. They need to have a wind uplift rating of 30, 60, or 90 psf. They need to have impact resistant testing at 100 pounds at 4 feet. And lastly, they have to have a Class A UL 790 fire rating for aluminum and HB flammability per UL 94 for domes. FM requires a little bit different testing, but some of it's similar. So the testing is 60 cycles testing opening and closing, which is a lot less than the 250 per UL. FM operates with a 360 degree Fahrenheit minimum rated heat sensing device, so not to activate before the sprinkler, so this is really in factories. It needs to operate manually from the floor level. The snow load, again, is 10 PSF, but it also has to do it in 10 seconds. The wind uplift is 60 PSF minimum. Impact resistance is 100 pounds at 4 foot, similar to the other, and fire exposure tests need to be done for the domes. Finally, just a reminder that smoke vents are essential to protect life and the safety of building occupants, so make sure that they are maintained and tested on a regular schedule. That requires weekly maintenance checks, 6-month inspections, and monthly tests. In summary of that section, NFPA has requirements for smoke vents in section 92, section 101, and sections 204. IBC codes to remember are sections 410 and 910. And lastly, smoke vents need to be compliant to UL listing and FM approved standards. Moving on to the next section, we'll be discussing how to choose the right smoke vent for your project. So for starters, what do we typically see for smoke vents on your standard F1 factory type buildings or S1 storage occupancy types? What we see is usually a standard 4-foot by 8-foot double door configured smoke vent. They usually have minimal components, real standard, with combined spring and dampeners, and are UL 793 listed and labeled. Also, we see them typically direct deck roof mounted or mounted on a curb built into the deck itself. Again, you can see a lineup of smoke vents, a bunch of 4x8s, all in a row to vent the building effectively. On the screen, you see a project spotlight of a Disney laundry facility. This is an example of a large smoke vent. These are quad leaf smoke vents. Basically, that's 2 double leaf smoke vents in one frame. They did this because they needed a large amount of ventilation, and they chose the oversized units to minimize the number of cuts in the roof deck. These also came with burglar bars because they didn't want the people to be able to use the manual pull on the roof to get in the building. There's a metal lid. It's motorized for opening and closing, and there is a custom curb on this particular smoke vent. There are also choices when it comes to smoke vent design. The industry standard, what we've seen so far on this course, is the hard lid units. But as the industry moves to more energy conservation, translucent smoke vents provide natural daylighting for the interior. You can specify polycarbonate domes or 3-wall, multi-wall polycarbonate covers in a variety of transparencies. In addition, they carry the UL 793 listing as well as the UL 746C compliance with UF light exposure tests for polymeric materials. It's also important to note that OSHA treats translucent smoke vents like they do skylights, meaning they require fall protection so a person in the roof doesn't fall through the smoke vent. Most manufacturers will offer fall protection mesh or a railing system, and a few smoke vent manufacturers will use translucent material like polycarbonate that passes the strict fall protection tests, so additional fall protection like mesh or a railing system is not necessary. There are also options for translucent smoke vents with an apron mount flange. It's a real simple smoke vent. It's a product designed to look kind of like a skylight, and many big box stores use this product along with a row of skylights for a consistent look and smoke venting performance. Here's another interesting project spotlight coming from the San Diego Zoo. There are, as you can see, a bunch of smoke vent varieties in different shapes and forms. This project replaced the existing operable skylights with a combination of metal lid and sunlit smoke vents. The zoo officials wanted to reduce the amount of light the skylights were allowing into the building while providing options for ventilation. The various smoke vents provide much needed flexibility for the animal occupied spaces. There are several options available for dome material on daylighting smoke vents. The most common is a clear single wall dome. It provides great light transmission but has a low R value. By doubling the dome, so a double dome configuration, you will increase the R value with a slight decrease in light transmission. Color options will also impact the transmission of light into the building, and you can see there are other color options such as clear, white, bronze, clear over clear, which is your dome, double dome, or clear over white, which is also a double dome type option. There is another option for daylighting, which is instead of a dome called a multi-wall. Multi-wall has an R value of 2.5. They come in a variety of colors with different light transmission and solar factors, which you can see on the screen. And you can compare them against the dome or the double dome in the previous screen. Here's an example of an application at the Post Office Distribution Center in Waltham, Massachusetts. This is a retrofit translucent project spotlight. By replacing hard lid smoke vents with translucent lids, this postal building was significantly improved without re-roofing and with minimal impact from construction. Essentially, the hard lids on 41 smoke vents were removed and replaced with curb-mounted, domed and labeled smoke vents, providing natural daylight and energy savings. This solution added a curb-mounted curb, a dome to the cover. Like I said, they're labeled smoke vents. These are easy to install. You didn't have to penetrate the roof at all. And now the new benefits are there's natural daylighting, there's energy savings. On the installation, time and labor savings were had based on not having to really mess with your roof and just replacing the smoke vent itself on top of an existing curb. So we've already talked about your big box facilities, your F1 and S1 factory applications. But there are also special considerations for smoke vents in theaters, and we already kind of touched on this per IBC section 410 3.7, which defines emergency ventilation for stages larger than 1,000 square foot in floor area with a stage height greater than 50 square feet. Typically, the emergency pull handle is rigged down to the floor level, so the vent complies with the supplemental manual opening requirement per IBC. Also, the vents must be labeled UL 793 or FM 440, which are the industry standard vent labels. With IBC section 410 requiring smoke vents in performance venues, the industry developed what's called the acoustical smoke vent. In real life, the acoustician works to design the perfect venue for sound, and then the fire marshal comes along and says, cut a hole in the roof to vent possible smoke. That's why the acoustical smoke vent was developed. Industry standard capability for smoke vents have an STC rating, and that STC rating usually is between 40 and 50. They also have OITC ratings, which are between 30 and 47. Higher is better, so specifying a smoke vent with an STC rating of 50 maintains the specification coordination with the ceiling assembly or even surpasses the soundproofness of the ceiling assembly. One little note, the acoustical rated smoke vents are usually painted black on the interior, making them disappear into the ceiling of the theater space. Now that we've talked about the STC rating and OITC sound rating, I think we need to talk about that a little further so that there's some understanding. But the STC is the sound transmission class, which is a single number rating for assemblies, and its ability to resist airborne sound transfer at frequencies between 125 and 4,000 hertz. So a low-pitched tuba would be about 25 hertz, where a high-pitched flute, you're talking about 2000 hertz, just so you have an understanding of the sounds. Indoor transmission class, which is the OITC, is a standard used for indicating the rate of transmission of sound between outdoor and indoor spaces. The OITC is weighted to lower frequencies at 80 hertz, which is like an aircraft, train, or truck traffic. The idea is when you are in a performing art center, you want to hear the performance and not the outside noises. Acoustical smoke vents address this issue and carry the STC and OITC ratings. International Building Code IBC 1207 recommends STC 50 for walls, floors, and ceilings. So specifying a smoke vent that meets the rating will maintain the specification coordination with the ceiling assembly is also something to think about. So far with sound ratings, we've talked about hertz as well as decibels. There is a rainfall rating, which goes on acoustical smoke vents typically, and that is measured by decibels, whereas the STC ratings and the OITC ratings have to do with hertz. So just a little definition of both of them. Decibels and hertz measure different aspects of sound. Decibels measure the intensity or loudness of a sound, while hertz measures the frequency or pitch. A sound at 140 decibels, as you see on your screen, is extremely loud and often described as the threshold of pain. Examples include a jet engine at takeoff or a gunshot. On the other hand, hertz measures how many times a sound wave cycles per second. For instance, a low-pitched sound like a bass drum might be around 60 hertz, while a high-pitched sound like a whistle could be around 10,000 hertz. So while 140 decibels indicates a very loud sound, the hertz would tell you whether that sound is high-pitched or low-pitched. They are complementary, but measure different properties of sound. Here's another project spotlight. This is an acoustical smoke vent project in Atlanta, Georgia. It's the Cobb Energy Performing Arts Center. It has an upper and lower deck and carries 2 levels of acoustical smoke vents for ultimate performance. These smoke vents include a manual winch operation, which is integrated with an electrical tie-in for smoke alarms, and requires coordination and collaboration with rigging and electrical and roofing trades during installation. You will notice the interior of the smoke vent is painted black, as I mentioned earlier, so when they are closed and the lights go out, the smoke vents virtually disappear into the ceiling. It is a consideration for specifying a smoke vent into a theater where they should not be seen. While many contractors will field paint the interior, they potentially damage links and moving parts like springs and dampeners. Field painting the smoke vents will typically void the UL listing, so in specifying a smoke vent for a theater application, require a black powder coat interior from the factory. Here's another project spotlight from the LeTourneau University, which chose a bronze Kynar finish on its smoke vent for a long-lasting finish that matched the standing seam metal roof that it was placed on. The curb mount option was selected to be placed on a curb supplied by others to match the ridges on the roof. So in summary of that section, typical standard smoke vents are usually a metal lid smoke vent in a 4 by 8 foot size. Translucent and daylighting vents are an option, and they provide natural energy efficiency, and they also come in a variety of dome or multi-wall options. Make sure to look for STC and OITC ratings when specifying smoke vents for performing arts centers and auditoriums. Specifying an acoustical smoke vent with an STC rating of 50 maintains the specification coordination with the ceiling assembly, or even surpasses the soundproofness of the ceiling assembly. Let's move on to the next section where we'll talk about thermally broken smoke vents. In this next section, we'll talk about a newer innovation or technology in smoke vents, which is the thermally broken smoke vent. In regards to a thermally broken smoke vent, what is a thermal break? Basically, a thermal break refers to a design feature that creates a barrier to minimize heat transfer between interior and exterior components. Essentially, it keeps the interior temperature of a building consistent regardless of the weather outside. So during the summer months, heat from an extremely hot roof wants to radiate through the smoke vent into the cooler building interior. While a standard smoke vent insulation helps to reduce this heat gain, the metal construction of the smoke vent itself facilitates the temperature transfer, which can lead to increased utility cost and condensation issues on the underside of the vent. In the winter time or in colder months, the same energy transfer principle results in heat loss from inside a building as well as increased energy expenses. The importance of a thermal break in a smoke vent lies in its ability to enhance the overall performance of the product. And we'll discuss the 3 reasons why it's significant in the next few slides. As discussed, the thermal breaks in smoke vents minimize heat transfer between interior and the exterior of the building, reducing thermal bridging and heat loss. This not only improves energy efficiency, but it also helps in maintaining consistent indoor temperatures, which can be crucial in preventing the spread of fire. This improves the building's ability to contain the fire within the compartment of origin, limiting property damage and providing additional time for occupants to evacuate safely. Excessive heat or cold can compromise the structural integrity of smoke vents, leading to deformation, warping, or even failure. By incorporating a thermal break, smoke vents are better equipped to withstand high temperatures without suffering damage, ensuring they will remain functional and effective in facilitating smoke evacuation. Thermally broken vents will mitigate condensation in cold weather climates. Thermally broken smoke vents are also designed with an element of low conductivity integrated between interior and exterior surfaces of the cover and the frame to reduce temperature transfer. As an added benefit, these same thermally broken components dampen vibration for improved acoustical performance against outside noise. By reducing unwanted heat transfer, particularly in regions with extreme climates, buildings can maintain more stable indoor temperatures and decrease the demand for heating or cooling, leading to potential energy savings over time. Thermally broken smoke vents also have a higher R value. And R value is what refers to as the specific level of thermal resistance provided by insulation materials used in construction. This designation indicates the thermal resistance value, which is a measure of how effectively the insulation material resists the flow of heat. Higher ratings signify insulation with a high level of thermal resistance. Insulation typically consists of materials such as fiberglass, mineral wool, or foam board, which are designed to trap pockets of air within their structure. These air pockets inhibit the transfer of heat by conduction, convection, and radiation, helping to maintain more stable indoor temperatures and improve energy efficiency. Thermal broken smoke vents play a crucial role in enhancing the energy efficiency, comfort, and stability of buildings. So in summary of that last section, we learned what a thermal break in a smoke vent is. We learned that smoke vents with thermal breaks contribute to the overall fire resistance of a building by reducing the potential for heat penetration through structural openings. We talked about the fact that thermally broken smoke vents are more energy efficient, and we talked about R values, which refers to the specific level of thermal resistance provided by insulation materials used in the construction industry. Earlier on, we talked about the fundamentals of smoke vents, about codes, types of vents, and thermal breaks, which leads me to the last section, which just has to do with a few additional smoke vent options that are available. The first consideration one needs to think about with smoke vents is unwanted access. Smoke vents are an unsecured opening with both internal and external manual pulls. UL 7903 requires that when you get on the roof, you need to be able to open the smoke vent with that external manual pull handle that we talked about. You can also see it on your screen. Make sure that you specify burglar bars if security is a concern. Also consult local jurisdiction, as many require burglar bars in situations you may not expect. So you can see you got a smoke vent on the roof. Somebody could easily pop that open if they were to get up on the roof, and they could get down and in your building. If you don't want that access, you can add what's called a burglar bar. They come in dimensions of steel rod in 1/2 inch or 3/4 inch dimensions, and then the rod spacing would be 6 by 6, which this probably is that we're looking at, 6 inch by 6 inch, or 6 inch by 12 inch. Aside from restricting outside entry with burglar bars, something else to consider is fall protection. Once the vents are open, you essentially introduce a hole into the top of the roof, which somebody could fall down into. A couple different ways to implement fall protection for a smoke vent is the traditional 4-sided railing system, which you see here, or an interior 4-inch by 4-inch mesh system, which we'll review on the next slide. So this is your 4 by 4-inch mesh. It's a 3/16 inch diameter rod steel. It prevents falls through smoke vents, protecting workers and building occupants. It meets OSHA and other safety regulations. It's very durable. It's made from high quality materials to withstand harsh conditions, and it's easy to install. It's designed for quick and easy installation, saving time and labor costs. In summary of this last section, smoke vent burglar bars ensure safety and security so no unauthorized entry can be obtained to the building from the rooftop, and fall protection options include things such as safety railings or mesh screens, both of which are OSHA compliant. And there you have it. That wraps up the course for today. You've learned many course objectives, and you'll leave today with several key takeaways. First off, we talked about smoke vents and life safety. You should be able to describe smoke venting applications and understand its importance to health, welfare, and life safety of building occupants. We talked about the fundamentals of smoke vents. You should be able to illustrate the fundamentals of smoke vents and their opening and closing functions. We talked about codes in depth. You should be comfortable with the building codes, requirements, and label certifications related to smoke vents. And lastly, we finished with product options, which you should understand the importance of things like a thermal break in a smoke vent. We talked about sizing, selecting the right smoke vents for the right application and the right products for your project. As you can see, there are many different options of smoke vents, so I would say feel free to consult any of the companies that make smoke vents for help with smoke vents, because they are life safety. They are an issue that there's a lot of options for, and as manufacturers, we'd love to help. So thank you for your time, and have a great day.